Download this code from codegive.com, link in the description below. Response Caching and ASP.NET Core 6.0, and beyond, with I/O pipelines. Response caching, a vital technique for improving web application performance, undergoes significant changes with the introduction of I/O pipelines in ASP.NET Core 6.0 and later versions. While the fundamental concept remains storing and reusing responses to avoid redundant processing, the implementation details shift substantially, often leading to unexpected behavior if not approached correctly. This tutorial will delve into these changes, explaining why previous approaches might break and providing updated, robust solutions. Understanding the problem, the old way and why it's broken. In earlier ASP.NET Core versions, prior to 6.0, response caching relied heavily on middleware positioned within the request pipeline. This middleware intercepted requests, checked for cached responses, and served them if available. The simplicity was appealing, but it presented several limitations with the introduction of I/O pipelines. 1. Middleware limitations. Middleware operates on a synchronous basis. I/O pipelines, on the other hand, are fundamentally asynchronous, built upon async enumerability and leveraging powerful features like cancellation and back pressure. Trying to fit synchronous caching middleware into an asynchronous pipeline leads to performance bottlenecks and potential deadlocks. 2. Early termination. The traditional middleware approach struggles with scenarios where caching logic needs to interact with subsequent pipeline stages. Once a cached response is found, the middleware typically short-circuits the pipeline, preventing downstream middleware or handlers from executing. This can be problematic if you need to perform tasks after the caching decision, example logging, analytics. 3. Integration challenges. Integrating custom caching logic with the new I/O pipeline architecture becomes significantly more complex than it was in the old middleware-centric model. The new approach, leveraging I/O pipelines for efficient caching. To effectively implement response caching within the I/O pipeline, we need to embrace its asynchronous nature and work directly with the stream of data. This means designing a custom iResult handler or using an appropriate built-in feature that's compatible with I/O pipelines. Method 1. Using response cache attribute, with caveats. The response cache attribute still works in ASP.NET Core 6.0 and above. However, it's important to understand its limitations in relation to I/O pipelines. It works primarily with controllers and action methods, not with middleware. Therefore, it doesn't directly address the asynchronous streaming scenarios inherent in I/O pipelines. It may not be suitable for highly customized caching strategies or complex scenarios where you need more granular control over the caching process. Example using response cache attribute *. Method 2. Building a custom iResult handler. This offers the most flexibility and control. We can create a custom iResult handler that checks for a cached response before processing the request and write the response to the cache. This allows for fine-grained control over caching behavior and seamless integration with the asynchronous nature of I/O pipelines. Example using a custom iResult handler *, simplified for demonstration. Important considerations *. Cache key generation *. Crafting robust cache keys is crucial. The example above is rudimentary. Consider using a more sophisticated approach that incorporates all relevant request parameters to avoid cache collisions. Libraries like Newtonsoft.json can help in creating hash-based keys. Cache invalidation *. Implement a strategy for cache invalidation. If the underlying data changes, you'll need to remove the stale entries from the cache to ensure data consistency. Consider using techniques like cache tagging or time-based expiration. Serialization choose appropriate serialization methods, like JSON, for storing objects in the cache. Error handling implement proper error handling to gracefully manage situations where caching fails or encounters exceptions. Cache provider the example uses iMemory cache. For larger applications, consider distributed caching solutions like Redis or MEMC8 for better scalability and performance. This tutorial offers a more complete picture of response caching in the context of ASP.NET Core's I/O pipelines. Remember to choose the approach that best suits your application's complexity and performance requirements. Using a custom iResult handler provides superior flexibility and control over the caching process, particularly when dealing with the complexities of asynchronous streaming. Always prioritize efficient cache key generation and invalidation strategies for optimal performance and data consistency.